Hey, welcome back. It's a mess in here, and it's my own fault. This is my daily driver. I've been driving it to work, and yesterday I snapped the input shaft end off, doing some maintenance. Um, yeah, it's kind of a nightmare. You basically have to pull the whole motor apart to fix that problem. So, that's why there's 4 exploded Derbi motors all over the floor, and today I'm going to rebuild a Derbi motor and show you all the steps that you need to do to rebuild a start 5 or start 3. I'll show you the damage and then we'll get right into it. So here's the damage. This should be attached to here, but as I was tightening the nut up with my impact, it literally snapped the end off. Now, I don't know if this was, it was my fault. I definitely left my impact on mode 3 and just gave it a quick burp, but it wasn't like tightened up. It basically just popped off the second there was any amount of load on there. And if you look at the back, it's real hard. You can see there was a crack. This is where the end of the center drill went. That was the center drill that went in here. So when they ground this, they would have put this on centers and ground all the diameters. And you can see right where the sharp edge is, where that transitions into the end of the point, that's where it snapped off at. And when you're hardening stuff, depending on the material, that's kind of can be a common occurrence where there's a sharp edge. You'll end up with a stress point, and it might be hard to see, but you can see the break. You can see it's how clean it is right around the middle there, which kind of leads me to believe that this may have already been cracked, but I don't really know. You never really know. Either way, it popped off. It just went poing, and this and the nut fell on the floor, and then created an entire headache for me. So, I have a couple of motors here on the floor. I don't have enough parts to actually make a whole motor. I don't have any new bearings. I don't have any new seals. So this is going to be not typical of my normal builds. I'm going to actually try and reuse some stuff until I get... The bearings I have are good. They're out of a low kilometer motor, and I pulled them out without... I heated them up and warmed them up and pushed them off without any real issue, and they feel very smooth, so I'm going to reuse those. But seals, I'm just going to have to go through and pick a couple seals that look okay, and wait until I get new ones. They can be changed on the fly on the outside later on. It's not a huge deal to do a seal. So yeah, let's get started. So after I broke that off, I went and grabbed my parts bin with Derbi motors, which is why you can see them nicely on the floor here. And I grabbed the best looking one, which was one that I pulled out of a running bike, and I took that and cleaned it up and disassembled it and pulled the crank out and bearings and stuff. And yeah, that's where we're at with that one. But for demonstration purposes, I'm going to show you how to get one of these apart without a crank puller, because for some reason since the move I also can't find my crank puller and I don't know where it is. So I do have a little tip here. I'm going to show you guys how to get these apart without a crank puller, or any motor really. It would work on any. It's not as nice. You still have to tap on the crank. However, with this you're considerably less force. These motors are also a bad example of that, because this input shaft actually presses into this bearing pocket on this side. So you still have to kind of drive at it pretty good to get it apart. You could put something in here and jack it, like if you had like a little stud with a nut on it, you could actually use that to go in here. This motor is kind of garbage. This crank is actually garbage. So I'm just going to drive this one apart, and yeah, I'll show you how I do that. So first things first. These Derbi motors are great because they actually use nuts and bolts all the way through. So they usually come apart pretty good. They won't corrode because it's a tiny thread into aluminum, and they're not screwdriver bits, which some motors have, which are awful and you need an impact driver on. They're quite easy to not burp out. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that actually splits the cases. Once you get those out of there, it's still stuck together. It's just now stuck together with the press fit of the crank and that input shaft. So you can see on this one here, I've already removed all those bolts. I've also drained the oil, which is this drain plug here. We might try and steal these crank seals because they look pretty new. If I can get them out without wrecking them. At least this side. The one on my other motor on this side didn't look very hot. That one looks like it's in crooked, but maybe you can save that one too. Either way, let's see what I can come up with. Using old crank seals for a couple of days isn't going to hurt anything as long as they're not leaking terribly. So, you need a torch. And you're going to warm up the cases around the bearing pockets. Pick a side, it doesn't really matter, but you want one side to come apart basically by warming it up. I like this side here, so cue heating montage. And the way to kind of gauge whether or not you're done is if it's hot enough that you can't really touch it anymore, it's probably hot enough for this to work. The reason why this works is the aluminum expands faster than the steel bearing, so it actually grows in size, bigger in relation to the steel. And once you are happy, if you are going to reuse this crank or try to, you definitely want to use a soft blow. Mine's pretty haggard. I might break out my brass hammer just because, again, this crank is no good. My faces are really bunged up, but let's give her a shot here. And you can see just like that, it split quite easily. Now I'm stuck on the input shaft on the back, so you gotta flip it over. Give it a couple whacks there. But don't try and see how I have like more here than here? Don't try and do one side more than the other or you'll break a dowel hole or something like that. And again, this isn't ideal. I would always recommend using a crank puller, but like I said, I can't find mine right now. And just like that, we're apart. However, the bearing stayed inside on this one. Now this one's been apart before. I don't know the general condition of this crank. I mean, it's pretty rough, so I don't know what's going on there. One thing you'll notice is when you pop this thing apart, you'll see these shims fall out of here. This actually shims the gear set in relation to there. It's pretty important to note which side they come from and how many there are. So just be advised that when you pop this all apart, there's nothing else really inside of this but those two shims, and they run on this face and they are kind of critical, so make sure they don't like fall out and disappear or something. Normally this bearing would stay in there. This bearing actually looks brand new. I feel like someone might have tried to rebuild this motor at some point in time. It's a little grindy. Another point of interest, if you were trying to rebuild this motor entirely, including the transmission, you'll need a blind bearing puller to get this out of here. This seal on this side is a 17 by 35 by 7. It looks like a double lip seal. this one's kind of falling apart. The other thing I glossed over was taking this thing off. I actually have a HPI puller, which is here in this bag that I got from Treatland, and it works on these two holes here, but it's really just a threaded hole with two holes in it. It's not like a weird internal thread one, so you could probably make this or find something else that works. Don't use 3 jaws on these. These are actually quite thin. If they're really stuck, I've seen these get completely destroyed with 3-jaw pullers. You're better off pulling off the hub here, which is like a solid piece of steel, whereas this is usually just stamped steel, and you will end up hurting it. So this here seal the crank seal looks like it is a 2037, and this input shaft seal is a 1735/7, this one here. So if you were rebuilding one of these and you wanted those seals, I would just look for generic seals anywhere. The bearings on the inside, these ones don't have any markings, but the other cases I will get the numbers off of those. So if you wanted to replace these bearings here and here and here, well, crank bearing, you're definitely gonna want to replace that probably. But these transmission bearings, input shaft and counter shaft bearings, I think the numbers are on the other set of cases I have, so I will have those at least in the description or whatever of the video, so you'll have those as well. The crank seal on this side is a 2035/7, and this input shaft seal I'll get from the other side, and like I said, I'll also have in the description the other bearing numbers off of all of these. So again, if you wanted to rebuild the whole thing, you could. This is the starter clutch plate. This is a great time to gun this thing and throw it in the trash if you're not using the starter shoes, which if you're on like a Revo with no pedals, makes sense because it doesn't do anything other than make your bike not want to roll when you're at low speed. So grind this flush, take a small drill, it's about the same diameter as that, come in here, drill down into here, and once you break through you can just pull it off and throw it in the garbage. This one's, somebody's had some problems with this one. So yeah, just to get the crank out, I'm going to try doing this on this side to show you that it should actually work. I mean, it does work. I think the problem is this crank is heavily worn on this journal, so the bearing stayed in there. But normally if you heat this up, the bearing will pop out just because it's easier than it sliding on the crank. But I'm just going to quickly bang this out just for... So that's it stripped. You can see it started to work what I was describing, how the bearing, it gets so hot that the diameter grows here, but unfortunately with my demonstration, I guess that's kind of the thing with doing these kind of on the fly, is my demo one, the crank that I used, their journals are pretty wrecked. I would say this motor has been rebuilt at one point in time, that's warm, and this crank probably had some spun bearings on it, which means these are no longer a tight press fit onto those bearings. So unfortunately, my demo didn't really display what I mean, but I think you guys will get the gist as to why that's beneficial, especially if you have like a good crank that's tight. You just don't have to beat on the crank nearly as much. It should almost pop out, and this side you can see it almost did, but unfortunately my victim here today has a really bad crank. But I mean, it's a good tip. You can even use the heat even with stubborn motors and using a crank puller. Just warming that up, sometimes you'll just hear it pop and it'll literally just come apart a lot easier. I've definitely had to break out the torch a few times, even using a proper case splitter. So since I need these seals, I simply just tap this out the rest of the way. It wasn't in there by very much. On further inspection, these cases are super rough. Whoever rebuilt this motor, looks like they did it with a hammer. They just pounded these in. You can see all the marks on the walls there where it went in crooked, and the metal shavings that are down in the bottom there. So, I mean, they also use red Permatex, not the good stuff, the cheap stuff, to seal it up. So, yeah, I'd say none of this stuff is really good other than just for the demonstration of how to get it all apart. That shows you how to get this motor apart anyway. There's not really a whole lot else I can show you with this. Key points being, get it really warm, it'll come apart a lot easier, and use a soft hammer. Let me clear some space here on the bench. Get this CNC stuff out of the way. If you wanted to see some CNC build stuff, let me know. I'm like halfway through a build, but can definitely jump you up to speed as to what I'm doing over there. It's my second build that I built one many moons ago, and building a slightly bigger one. So through the magic of television, we have 2 good cases. Just kidding, I did these last night. So we have to prep these things. Usually what I like to do is I glass beaded these, so I will clean out the holes with the tap. Probably just going to do that off camera just to save time, because if you do have a little bit of glass in there, you very easily gall the thread up and lock your part up, or lock your bolt up. And you also just want to give your cases a good once over, make sure you don't have any dings or anything like that from transport or moving them around. That's going to keep your cases from going together. You can take a small file, lay it flat, and just kind of go over the surfaces very lightly. Just if there's any high spots, they'll go away. On these Derbys, it's important to make sure your bushings here are good. At least on the Revos, they will walk around and the bushings will eventually fall out. I actually have a case set on the floor there that's happened to. But yeah, they're easy to replace now versus when it's together. So another thing to do. Even though I have a paper gasket for shim, proper thickness of the cases to shim it, I also like to use 3-bond liquid gasket on everything. It doesn't add very much, but it definitely helps with making sure that it stays sealed, especially these separated, like windowed cases, so you'll actually have the gaskets all one piece, and you can glue all your pieces down, then it stays in place and you don't end up having it like walk out of the way. So nice to have as well. You'll also need a crank puller. I know I was saying crank puller, but I meant case splitter earlier. You can make that out of a piece of pipe. You can go to the hardware store and get friggin' thick wall black ABS pipe and some washers, and you can pull it in using the crank threads. It's not the best method. I've showed it here on the channel before, but it'll work. It's a lot better than pulling it together with the case bolts, which is just the worst. Like, just don't do that ever. It's so bad for everything. We'll get the other pieces out on the bench and we'll jump back into this. So in my build, I'm going to be using a new crank. It's a Barricade Derbi Variant Competition. Looks like this. It's pretty nice. It's like a semi-stuffed crank. It's not fully stuffed. I mean, it's pretty close. It's still got quite an opening here, but a little more balanced. Hopefully shake a lot less with my 70 kit. These are my new used bearings that I salvaged last night. I put them through our wash tank and just coated them with a light oil. So these are Nachi, but you can use any bearing. I would use like probably a C3 clearance, just so they have a little bit of give to them. It's a 6204 for both sides of the crank. So that's that one there and that one there. To install these, we're going to actually probably do the same thing, very similar to what we did to get them out of there, is just warm this up a whole bunch and then just push them in there. And I may jump out of frame when I'm doing this, just because I may have to go to the arbor press if it doesn't slip in all the way. All right, so they're both in, and let them both cool down. If it doesn't go in, don't drive it in. You'll end up with metal shavings in behind the bearing. You'll end up ruining the bores. The heat just makes this so much easier. Like, you honestly don't need to beat the bearings in there, and the heat won't hurt anything, and you're not like melting the aluminum. It's hot, but it's not like stupid hot. I mean, I can still touch the case. It's warm, it's uncomfortable. Probably if I held my hand on there for a long time, it would probably burn me, but you know, it's so much easier, and it just saves the cases. Same as putting the crank in. I'll often take electric heat gun and I'll warm this up, including the bearing, and then slide the crank in. So much nicer, and I will show that here in a minute. Next step in this journey is you're going to prep the cases to be put together. So again, these two shims go here. They act as like a thrust bearing, sort of, so to speak. So they cooled down enough here that I can probably put the goop on. It's not gonna bubble away. So the dowels are on this side, so I'm gonna use this side for the alignment of the paper. Less is more. It's not like silicone where you need to like put a literal ton of it on there and then have it. I mean, really with silicone, you don't need to put a literal ton of it on there either. But you do just want to basically coat it. You don't want it to like smear out and go all over everything. That's not, this stuff is meant purely to fill in like the small imperfections in the surface. You'll have to excuse my neighbor installing a fence. I can't really get that out of here. Hopefully the directional mic is keeping most of that away. He is literally on the other side of my garage wall. This is the only gasket I think I really need to use out of this kit, other than maybe the base gasket. Possibly the intake ones, but those are a different kit. So you can see it's got this paper bridge that holds it all in alignment. Don't cut those yet. You cut that once you get all the case halves together. Go around and just align it by the holes. Again, the good thing about the glue is it'll keep it pretty in place while you fuss with everything. You might need to tear this one. This one looks like it's a little tight on the top there, but don't leave the ears on it because you'll cut those off again once the case is put together. I know in a lot of cases I'll actually just not use a gasket, which can be fine. On this one, for spacing of the transmission, probably good to use a gasket. It's usually, the clearance for all of these stacks is usually including the gasket. That said, you do you. If you don't want to use this stuff and just want to use MotoSeal, you're more than welcome to. I'm sure it will turn out just fine. This gasket is shrunk like crazy. What do I mean by shrunk like crazy? Gaskets over time, if they've been on the shelf, I don't know, I think they just get moisture in them, and then they kind of twist and contort and bad stuff happens. You can see I'm struggling to try and get this to align with all the holes at the same time and yet cover all the important parts. It's because it's kind of shrunk. But these holes don't really matter, so I would rather have gaskets on the edge and then make new holes. And I think I'm going to do my second coat of stuff just onto this paper instead of just doing it on this half. So the next step, we're going to install the crank. I'm just going to warm up the bearings and then hopefully slip it right in. So that was not super painful. So now we're going to do the same trick to this bearing, then this bearing. You don't really want to heat it up crazy hot like the other ones, but you definitely want to get it kind of warm. If you overheat it, you can mess up the bearing if the inner race grows faster than the outer. But I mean, just get it so it's warm. Probably should have thrown this in here already. Shoot. Also, because there's seals pre-installed, normally I don't do that. I'm in a bit of a moment here where I'm just going to put a little bit of oil on this shaft because it goes through a seal, and you should really pre-lubricate your seals if you're putting them together. Hot. Take my shims, put them on this side, put this case out, and if everything goes okay, this will mostly push together, but I'm prepared for it if it doesn't. Alright, that did not go great because the gear caught up, so I'm going to need to bust out the crank puller and pull the crank on the rest of the way. This is where I find actually just keeping old bearings around is super helpful, because oddly enough, you can do stuff like that. Basically, you're going to need to wind a nut down, add more washers, wind the nut down, add more washers, and just keep going that way. So I'm going to say again, this really isn't my favorite way to do this, but this is the only way I have right now. So what you do is, if you can find a soft piece of something, you can put it in the rod and wind against the rod. So here I have a rubber coated handle for a pair of pliers. That'll probably do the trick. Yep. And don't go crazy, just nice and slow. Once you think you've hit the bottom, you're going to want to take the nut off. So wind it around the other way. Add another washer to your stack, or maybe take one off in this case, because I don't like how much I have engagement. You do want a fair bit of engagement. You definitely don't want to mess up the threads on your crank. So I mean, it's better to go slow and just add one washer at a time if you don't have a lot of engagement on the thread there. And I am going to be ordering a new crank puller here, because I again don't like doing it this way, but I don't have much of a choice. And as you're pulling it down, things to note: make sure your rod is in the hole in between here. I have accidentally had my rod up in the intake before. Real annoying. Not on these cases, but on other cases. Make sure your gaskets on this little window are all good. And as you're getting to the final bit, make sure your gasket's gonna seal, and then give her the beans, I guess. Oh, got it together. Cameras both died conveniently, or inconveniently, but we'll just finish this out on the GoPro for today, because there's not really too much more left to do, and probably be just a part 2 after this of putting the other parts off of the other motor and all the accessories on. So we're going to put our case bolts in. Try to remember where the really long one goes. It goes in this corner. Sorry. And if you're a stickler for weird things, all the original ones, the bolts go through this side and the nuts are on the other side.
just gunned all those on the lowest torque setting, which is only, I think, 20 some foot-pounds or something like that. And you just want to tear off your tabs, just fold them back and forth a couple times, get those out of the way. Then follow up with a razor blade and just trim them short. Next I might top up the transmission just to make sure it's not leaking. Alright, so that's done. About 150 milliliters of fluid in there, if you were counting. Now there is a drain hole or a vent hole right here, so it's not leaking out of the bottom. I think that's all I really need to see. As long as it's not leaking out into the crankcase, that's the other direction it can go. Just tip it this way and see if I get any sweating. But if you tip it upside down, it'll come out of that vent hole, so not ideal. It's not leaking out of either of the seals, it looks like. So that's a success, mostly. Alright, so last up is the crank seals. Get some two-stroke oil. What I like to do is try and put like a drop just in on the bearings and also on the shaft. It's a lot, but that's alright. Flip it to the other side here. Do the same process. Try to without spilling any more oil. Move the inside of the seal. Very gently. Bit of a pain, but so what I'm doing is that the inner lip here is catching on this sharp edge. So I'm just taking something very fine and just kind of aiding it over the end very carefully. I wouldn't really even like roll it around. I would just kind of give it a little push. Make sure your tool is covered in oil and the seal is covered in oil, and you shouldn't tear it. Just like that. And if you got strong thumbs, you can probably just push it in there as long as it's fairly square. And there we go. Crank seal in. Crank still spins nice. Input shaft spin nice. So that's it. That's the bottom end assembled of a Derbi Revolution Start 5. A whole bunch of stuff. Start 3 would probably be very similar. Use a slightly different input shaft or output shaft style, but it's similar-ish. Okay, so that's pretty much the end of that. We won't get into putting any more, like the cylinder studs on and all that stuff until we pull the other motor out and pull all that stuff off. I have an intake on that bike and I have a 70 kit, so we will wait for that. One last thing I'm going to check here, just for funsies, is I want to put an MVT on this because I want to put an inner rotor on. So this is a Piaggio backplate. It actually almost fits, other than you need to open this up by about 1 millimeter. So I threw it on the lathe and opened it up. And the other issue is the bolt holes here aren't quite the same. They are really close, but they are not quite the same. They're off by maybe like 0.5 millimeter. So you could always just re-drill 2 new countersunk holes in this, about 1 millimeter, 0.5 mil to 1 mil out in a different position. That would work totally fine. This is an adapter I bought off a gentleman named Tyler on mopedarmy, but it wasn't meant for an MVT. It was just flat on the surface, so excuse the really rushed machining last night trying to get it going. Just took out a really long boring bar, so it's got quite a bit of chatter, but I just wanted to make sure that it would work before I have another one of these, so I'm probably going to make one that's nice. His is a bit nicer because it's thicker here. These are prone to stripping out if you over tighten them on the MVTs. You really have to be quite gingerly with it. So this just goes on like so. MVT can go on. So and the reason I want to run this is I want to run a curved ignition on it because it's a non-curved CDI style thing right now. So that goes on like that. And then, oddly enough, Piaggio base plate is really close to the same, but a Minarelli taper is really close to the same on this. So I modified this last night, hoping that I would get the weights in the right spot, and it looks like I did. So what I had to do was, this looked very similar to this. I cut the outer flange off. I'm going to have to drill and tap 2 new polar holes here. That's not a huge issue. And then the other thing that I did was the height of it. So I moved this back about 120 thou, all of these features. So I put a new groove in there to move that back. And that should clear. And like I said, the taper is good, so that'll lock on there. And the only other hiccup I'm going to run into here is I may have to make a new oil pump drive. We shall see, which is that weird nut, because I do run the oil pump because this is just a daily. Wherever that weird nut went that I was using earlier. Anyway, it's just a nut that goes on here, but it has a slit cut in it, so I may have to make something up that drives the oil pump. But yeah, it seems like that's going to work. Let's just pull this off and see the clearance to the back of the plate, which was the hiccup. So if I was to use a regular one, this goes too far deep into here, it would actually rub on these bosses here, so that's no good. So I think that's it for today. There's going to be a part 2 where I put this thing in the bike and pull all the parts off of that and bolt it onto here. Might do a leak down test on it if I have enough time. But yeah, that's it for today. Until next time, take care.